Hey everybody, welcome back to another round of astronomy. Yeah, let's get going. As mentioned, we're going to take a small detour and discuss some more of the observational astronomy features before we jump back into the quantitative models, the equations, if you will. So, observational astronomy, I guess the other way that we could talk about this is what is called celestial dynamics. How does the sky change from hour to hour or from week to week, etc., etc.? And so we're going to cover a couple of different topics all encompassed in this chapter. So first of all, we'll cover the daily and nightly motion of the stars. And right here, we're going to take advantage of that celestial sphere model from ancient Greece, stationary Earth and a moving sky. We will then progress on to a discussion about seasons, and in particular, talking about the axis of the Earth's and also the amount of daylight that we receive. After that, we'll get into something about annular motion, how the stars change from month to month to month. And lastly, we'll wrap up with calendars, which is kind of the place where I get really jazzed, probably because I didn't really understand it that well before I started learning how to teach the class. So, you ready to join me? Let's get at it. Some questions for you. So first off, how far does the Earth rotate in 1 hour? Go ahead, take a minute, see if you can come up with an answer. Yeah, you got it? Yeah. You know that a full rotation is 360 degrees, and that is what we call 1 day here on Earth, a 24-hour period. So we're just going to simply take 360 and we're going to divide it by 24. And so if we do that, you could say, okay, well, you could pull out the common factor of 12, and so you end up with 30 divided by 2. That gives you about 15 degrees an hour. So again, now let's add this in to our things to look for. So number one, you go outside, you start looking for the star chart, practicing the star chart. Number two, you go outside, you look at the time and look at the position of the moon and the phase of the moon. Okay. Here's a third one to start looking for. If you go out at night, say you're walking to the CC and you look up and you see the stars, okay? And then you come out from eating and look at the stars again, okay? You should see, if it takes you about an hour to eat, you should start noticing that those stars are shifting position. And you can get an idea about how quickly they're moving across the night sky. Okay? Good. Well, let's use that idea. Here's another question for you. Okay? Explain how you would determine the exposure time for this photograph. In fact, after you have that, see if you can estimate how long this exposure time was. You got it? Yeah, good. So if we know, well, let's go this way. If the exposure were a full 24-hour period, okay, these star trails, what would the shape of those star trails be? Yeah, good. A full circle, right? If we followed that star for a full 24-hour period, it should complete an entire loop and return to the same position. So we can see that the stars aren't completing a full loop. So we know it's less than 24 hours. Well, what happens if it completed half a loop? Yeah, good, 12 hours. Or maybe if it completed 1/4 of a loop, it would be about 6 hours. So how do we get the exposure time? We need to estimate how much, what portion of the loop has been completed, okay? So I'll take this one. Sorry, it's a little off there. PowerPoint doesn't let me draw lines exactly where I want them. But I'll say, okay, well here, this looks like it's a little less than 1/4 of the way around. Okay, so I estimated it to be about 75 degrees. Okay? It's less than 90, it's greater than 45. I just took 75. And if we want to really get the exposure time, all we have to do is say, okay, well, we know the Earth rotates at 15 degrees an hour. And if I have 75 degrees, I can set up a proportion, right? And so I get something like roughly 5 hours. Next question. Using this photograph, so we've got an idea about how long the exposure was for. I have another piece of information. Using this photograph, identify the cardinal directions. In other words, which way is south, which way is north, etc., etc. Take a minute, go ahead. You got it? Good, 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 good. Yeah, and where's the key? I've told you that it's in Texas. So what's the key thing that we need to look for here? Yeah, can you find the North Celestial Pole? Yeah, you see the center of the circle is right there, right? And oh, look at that bright star close to the North Celestial Pole. That star is, yeah, good, 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 good. It's Polaris. Okay, good. Which means if I start walking towards Polaris, I am essentially moving north on the Earth, right? So north is something like that way. Okay. And now I've got all my cardinal directions. You follow me? Yeah, who knew you could get so much from a photograph? Next question. Okay. Same photograph. Which direction do the stars appear to move? Yeah, you got it? Don't forget, you know which way is east, right? You're essentially facing northeast in this photograph. East is over here. Yeah. Let me ask you this. Okay? What causes the sun to rise every morning? What's that motion actually due to? Yeah, good. The rotation of the Earth. So we're going to use that idea. The sun rises in the east. We can confidently say that all of the stars will also rise in the east. Okay? And so since this direction over here is east, we know that these stars must be rising over the eastern horizon. Okay? So these stars appear to be going counterclockwise around Polaris. Good, good, good. Now, bear in mind, if I were facing south, the stars would still be rising in the east, and then they would appear to be moving clockwise. So you got to pay attention which way you're facing. Okay, next question for you. Ready? Here we go. If you stood at the North Pole, okay, so let's say we walk all the way north, and we're on the North Pole. What do you think the star trails are going to look like? Again, this one doesn't have any kind of calculation answer. I'm asking you to conceptualize. What do you think the star trails are going to look like? Hey, you got it? Yeah, good, good, good. So if I start walking north and north and north, okay, what's going to happen to the altitude of Polaris, the angle between the horizon and where Polaris is? If I start walking north, is that angle going to get smaller or is that angle going to get larger? Yeah, it's going to get larger. I'm going to walk north and Polaris is going to get higher and higher and higher in the sky until right when I'm at the North Pole, I look up at zenith and boom, there's Polaris. Okay. Next question. Polaris is on the North Celestial Pole. What does the shape of the star trails look like? Yeah, they should be circles, and they're going to be centered on Polaris, which is directly at zenith. So if I look up and I could take a long-term exposure, I should see circles going all the way around Polaris. Yeah, like this, right? If I walk all the way to the North Pole, I've got all of my stars circling around the North Celestial Pole. Cool, huh? Another way to say it is that when I'm standing on a pole, a geographic North Pole, a geographic South Pole, every star is going to be circumpolar. All of the stars are going to, any star I can see, I'll say except for one, any other star is going to be circumpolar. They'll just do these circles around Polaris. Yeah. Now, I will mention, I said except for one. This is the exception to the rule. Which star do you think is the exception to the rule? Yeah. The sun. Because the Earth orbits the sun, it's going to change its position. Yeah. Good. Second question for you. This picture I have for you. Which pole was this taken in? And how do you know? Is this the North Geographic Pole or the South Geographic Pole? Yeah, it's the South, right? Right? Notice right here in the center, there is no bright star. And so we're actually looking, this is taken at the South Pole, geographic South. I apologize. I couldn't find one for geographic North because I don't think we actually hold a permanent research base there. Okay. So we are now at the geographic North Pole. All of the stars are circumpolar and they're forming concentric circles centered on zenith. Okay. Well, what happens if we walk south? As we walk south, what do you think the star trails are going to look like as we walk south? Yeah, you got it? Good. Well, you can imagine taking this image, and now I'm going to walk to the South Pole. Excuse me, not South Pole, the equator. And that's like, we see this. We should now see all of the stars. They're going to rise in the east. They're going to come up over my head, and they're going to set to the west. Okay? In other words, no star is circumpolar, right? You get to see every star. Cool, huh? The other thing I'll mention is that at the equator, when the stars set, they're gonna be, the star trail is gonna be perpendicular to the horizon. Okay? As you walk from the equator towards the geographic poles, you'll notice that those star trails will make a steeper and steeper angle with the horizon until they're parallel with the horizon, at which point you're at the poles. Yeah, cool, huh? Yeah, good. Okay, so I've got a couple questions for you. That's all we're gonna deal with for the nightly motion, the daily and nightly motion. Okay? And probably the big thing to keep track of is that 15 degrees per hour. That's how much the sky will shift from night to night to night, or excuse me, hour to hour to hour. Okay? Shift about 15 degrees every hour. Okay, well, question for you. Let's check this. Okay? Say that the sun is currently in Gemini. So we go out and pretend that we can see the background constellations. We have the sun, it's in the constellation Gemini. 6 hours later, which constellation will the sun be located in? Go ahead, give me an answer. You got it? Yeah, good. And I ask this question because we have to be careful. We often think about the sun moving and forget that the background stars should be moving as well. So be careful. If you fell in for this, if you said, well, if it's 6 hours later, the sun should move about a quarter of the way around its orbit. And so it should be about 90 degrees away. So if it starts here in Gemini, 90 degrees, it'll be somewhere over here in Aries. Okay? And again, if you said that, that's okay. Bear in mind, why does the sun seem to move? Because of the rotation of the Earth. Then you realize, well, if the sun is shifting across the sky because of the motion of the Earth, the background constellations should also shift across the sky. In other words, Gemini will still be behind the sun, and you'll have new constellations showing up and some constellation setting. Okay? So yeah, be careful. Okay? Just, it's okay. We're still working on developing this intuition. Okay? Well, I think that's all I have for this lecture. So I thank you for your attention. Keep up the good work. Be sure to ask questions as they come up, and I'll see you next time.